What if I told you that the extinction event that changed the world the most isn't the one you're thinking of? We've all heard about the asteroid that wiped out the dinosaurs, the one that hit Earth around 66 million years ago. It's a dramatic story. Fire from the sky, giant lizards gone overnight, and the rise of mammals. Hollywood loves it, and kids love it. And to be fair, it's a pretty wild event. But here's the thing, that extinction wasn't the worst. There was another one, a bigger and deadlier one. It didn't come with a single dramatic bang, but instead, a long, choking spiral into chaos. It nearly erased life itself. This event happened 252 million years ago. It's called the end Permian extinction, although many scientists simply refer to it as the Great Dying, and for good reason. It wiped out about 96% of all life in the oceans, around 70% of animals on land. This wasn't just a bad weekend for life on Earth. It was a total system collapse, and yet most people have never even heard of it. So in this video, we're looking into the real story of the Great Dying, how it happened, what it destroyed, and why it might be the most important extinction event we've ever faced. Let's go way back to 252 million years ago, to the day Earth almost hit the reset button. Before Earth nearly hit the reset button, it was really thriving. This was the Permian period, a time that lasted from about 299 to 252 million years ago. The planet was warm, much warmer than today, and most of the land was fused into one giant supercontinent called Pangaea. There were fewer boundaries between land masses, and climates were extreme. Deserts stretched across the interior, while tropical zones hugged the coasts. Still, despite these challenges, life was booming. In the oceans, marine biodiversity was off the charts. Strange and beautiful creatures filled the seas, trilobites with their segmented bodies and bug-like eyes, brachiopods clinging to the seafloor like underwater clams, and ammonoids which look like coiled-up nautiluses and are the ancestors of modern squids and octopuses. Coral reefs, though made of different species than today's, were already forming underwater cities teeming with life. These seas were full of color, motion, and complexity. Life had spent millions of years refining itself into countless forms. On land, evolution was getting bold. Synapsids, also known as proto-mammals, roamed the landscapes. Creatures like Dimetrodon with its giant sail-like back ruled the food chain long before the first dinosaur appeared. Early reptiles and amphibians explored rivers, lakes, and forests that were dense with primitive trees, ferns, and towering seed plants. Insects buzzed through the air, some of them huge by today's standards. These ecosystems were incredibly diverse and surprisingly advanced, setting the groundwork for everything that would come later, including us. The world wasn't just surviving, it was innovating. But beneath this vibrant surface there were weaknesses. Earth's systems, climate, ocean chemistry, and carbon cycles were complex but not invincible. They had reached a sort of delicate balance, like a tightrope walker in perfect stride. One strong gust, one powerful shift, and it could all come crashing down. Unfortunately, that gust was coming, and when it hit, it didn't just knock things over. It unraveled the very fabric of life itself. It all began in what is now Siberia, a place that, 252 million years ago, became ground zero for one of the most violent episodes in Earth's history. A massive volcanic event called the Siberian Traps eruptions spewed out lava, gas, and toxic fumes for nearly 1 million years straight. We're not talking about one or two volcanoes either. This was a region with rivers of lava flooding the land and smoke blanketing the skies. These eruptions released unimaginable amounts of greenhouse gases, mostly carbon dioxide, into the atmosphere. In fact, CO2 levels skyrocketed from around 400 parts per million to a staggering 2,400 ppm, which is over 6 times higher than today's already troubling levels. As this carbon built up in the atmosphere, the planet began to heat up. Not by a little, global temperatures soared by as much as 10 degrees Celsius, 18 degrees Fahrenheit. That kind of increase doesn't just mean hotter summers. It reshaped entire climate systems, disrupted rainfall patterns, and altered wind currents. Earth was thrown into a chaotic, feverish state, and the biosphere began to buckle under the pressure. What's worse, these eruptions weren't just a one-time event. They happened in waves and pulses of destruction, each one pushing life closer to the brink. This wasn't just a regional disaster. The gases and particles released by the Siberian traps entered the upper atmosphere and spread across the entire globe. Every continent felt the heat. Every ocean began to shift. These eruptions were the trigger, but they set off a chain reaction of environmental collapse that no species could outrun. And unfortunately, this was only the beginning. As Earth heated up, the consequences were swift and brutal. Oceans absorbed the heat, becoming warmer and more stagnant. Warm water holds less oxygen, and with the rising temperatures, oxygen levels in the ocean started to plummet. Eventually, huge parts of the seafloor turned into anoxic dead zones, places where no oxygen meant no life. Researchers estimate that over 50% of the world's ocean zones became lifeless, wiping out entire food chains. Imagine massive swaths of ocean turning into toxic, suffocating deserts, and you're starting to understand the scale of this disaster. But the oceans weren't just losing oxygen, they were also turning to acid. When CO2 dissolves in seawater, it creates carbonic acid, which lowers the pH of the water and makes it more acidic. This was catastrophic for marine life, especially creatures that relied on calcium carbonate to build their shells: corals, mollusks, and plankton. The acidic waters literally dissolved their shells, making it impossible for them to survive, let alone reproduce. Coral reefs collapsed, and with them, the intricate web of life that depended on those ecosystems fell apart. The ocean, once teeming with ancient creatures, was becoming a graveyard. And the sky wasn't safe either. The Siberian eruptions also released sulfur dioxide, which mixed with water vapor in the atmosphere to create acid rain. This rain didn't just sting, it killed plants, stripped soils, and weakened ecosystems on land. Trees and crops wilted under its touch, and entire forests may have fallen. Even worse, the volcanic activity might have released halocarbons, chemicals that deplete the ozone layer. Without that protective barrier, ultraviolet radiation from the sun blasted the planet's surface, causing genetic damage to animals and plants alike. The very sky had turned hostile. Methane feedback loop. As if things couldn't get worse, they did, thanks to a terrifying feedback loop. The warming triggered by the Siberian traps may have melted permafrost or destabilized methane clathrates under the sea. These clathrates are like frozen cages that trap methane, a greenhouse gas much more potent than CO2. Once released, methane supercharged the warming process, pushing temperatures even higher. This wasn't just an add-on to the crisis. It was a runaway effect, where warming caused more warming, which caused even more methane to escape. It was Earth's version of a death spiral. Once it started, there was no stopping it. From fire and lava to acid and gas, every natural system on Earth was pushed beyond its breaking point. And as the planet unraveled, life, once so rich and diverse, was left gasping for breath. The next chapter would not be about survival. It would be about who didn't make it out. If there was one place that truly bore the brunt of the end Permian extinction, it was the ocean. Around 96% of all marine species vanished, a staggering number that makes this event the most severe extinction in Earth's history. Entire ecosystems were erased. Iconic creatures like the trilobites, which had thrived for over 270 million years, disappeared completely and never returned. These weren't obscure animals. They were once some of the most successful life forms on the planet. Coral reefs, which had supported a wide range of marine biodiversity, collapsed and didn't recover for millions of years. The warm, acidic, and oxygen-deprived waters made it impossible for reef-building organisms to survive, let alone rebuild. Other species like brachiopods and ammonoids, both of which had once dominated the seas, saw their populations crash dramatically. Some managed to cling on, but they were never the same again. With plankton populations also decimated, the entire base of the food chain was gutted, leaving nothing for larger predators to eat. What made this loss so profound wasn't just the sheer number of species that died, it was how foundational those species were. These weren't just fringe organisms. They were the backbone of ancient ocean ecosystems. Their disappearance set back marine evolution by tens of millions of years. After the extinction, oceans entered a long period of biological silence. With simplified ecosystems and limited diversity, it took an incredibly long time for marine life to bounce back. And even then, the world they rebuilt was vastly different from the one they'd lost. The story on land wasn't much better. Around 70% of terrestrial vertebrates, animals with backbones, were wiped out. Among them were the mammal-like reptiles known as synapsids, which had once been dominant across the Permian landscape. Some of these creatures were the distant ancestors of mammals, including us. The extinction cut off entire evolutionary branches, erasing countless possibilities for what life on land could have become. Even insects, which are usually resilient in the face of extinction, suffered massive losses during this event. In fact, this is one of the only mass extinctions in Earth's history that significantly impacted insect populations. Forests and habitats were destroyed by acid rain, climate stress, and oxygen drops, leaving these smaller creatures with nowhere to go. Many of the insects that did survive were drastically reduced in diversity and abundance. It's rare for a global event to knock out the tiniest survivors, but this one did. Terrestrial food chains collapsed. With so many herbivores and predators gone, the entire web of life on land unraveled. It was like nature hit a reset button. The survivors were scattered, isolated, and adapted to the harshest conditions, setting the stage for a radically new world in the aftermath. Even the plant world wasn't spared. Across large parts of the planet, forests disappeared almost overnight, stripped bare by a combination of acid rain, heat stress, and wildfires. Trees simply couldn't survive in the new conditions. High temperatures, acidified soil, and unstable weather patterns made regeneration nearly impossible. Widespread deforestation led to barren landscapes that stretched for thousands of miles. While some regions managed to see a patchy recovery, the global picture was one of devastation. The carbon cycle, so crucial for balancing Earth's climate, was severely disrupted. With fewer plants to absorb carbon dioxide, the greenhouse effect intensified, fueling the vicious feedback loop. Fossilized pollen and plant spores from this period show a drastic decline in diversity, confirming the scale of loss. This wasn't just a change in scenery, it was a breakdown of one of Earth's most important life support systems. And like with marine life, it would take millions of years for lush forests to return in full force. The fingerprints of this extinction are still visible in the rocks beneath our feet. One of the most telling signs is a sharp spike in carbon isotopes, which points to an enormous release of greenhouse gases into the atmosphere. This chemical signature is found in rock layers around the world, marking a clear boundary between life before and after the catastrophe. Another unusual clue is the sudden rise of fungal spores in the fossil record. Scientists interpret this as a sign of mass decay. With so many dead organisms, fungi flourished as they broke down the remains. The rocks remember what life forgot. In the immediate aftermath of the end Permian extinction, Earth wasn't just quiet, it was broken. Ecosystems had completely collapsed. With so many species gone, especially the primary producers like plankton and plants, the foundation of the food web was shattered. Without producers, there would be no food for herbivores. And without herbivores, top predators had nothing to hunt. The natural order, millions of years in the making, had unraveled almost overnight. Life didn't just go extinct, it lost its structure. In the oceans, recovery was slow and painful. Plankton populations, vital for oxygen production and nutrient cycling, were severely reduced. Their disappearance caused a ripple effect, starving larger organisms and keeping food chains short and fragile. The oxygen-starved waters, known as anoxic zones, persisted for millions of years. These vast, dead zones made it nearly impossible for complex marine ecosystems to form. Coral reefs, which had once flourished, remained absent for a long time, forcing marine life to adapt to simpler habitats. Species that could tolerate low oxygen and extreme heat, like certain bivalves and gastropods, were among the first to bounce back. On land, the situation wasn't any better. Forests had been decimated, and the soil was unstable from acid rain and drought. The few surviving plants had to recolonize barren landscapes from scratch. Herbivores struggled to find food, and predators were rare or entirely missing. Earth's climate remained unstable, and intense heat waves made conditions even more hostile. It took 5 to 10 million years, an eternity in evolutionary terms, before ecosystems began to resemble something stable again. And even then, the world that emerged was drastically different from the one that had died. Out of this chaos, however, came a new beginning. The mass extinction didn't just erase life, it cleared evolutionary space. With so many dominant species gone, new groups had the chance to rise. Among them were the early archosaurs, the ancestors of crocodiles, pterosaurs, and eventually dinosaurs. These creatures began to diversify in the Triassic period, taking advantage of the open niches left behind. At the same time, a few mammalian ancestors, small, warm-blooded synapsids, managed to survive. Though they lived in the shadows of the coming dinosaur age, they were laying the foundations for what mammals would eventually become. The oceans also saw a transformation. Modern corals slowly began to appear, along with new types of marine reptiles like ichthyosaurs and plesiosaurs. These creatures filled the roles left by extinct marine predators. While it took millions of years, evolution was quietly rebuilding the complex systems that had been lost. The recovery wasn't just about bouncing back. It was about redefining life's direction. From the ashes of the Great Dying, Earth launched a new chapter, one that would eventually give rise to the age of dinosaurs, the rule of mammals, and eventually us. If the end Permian extinction was the most catastrophic event in Earth's history, why isn't it common knowledge? Why don't we see documentaries, blockbuster movies, or even classroom posters about it? The short answer, it's complicated. And it doesn't have the flair that modern storytelling loves. The long answer? Let's break it down, because understanding why this mass extinction is so overlooked is almost as fascinating as the event itself. First, let's talk about the dinosaur distraction. The KPG extinction, which wiped out the dinosaurs around 66 million years ago, has become the poster child of mass extinctions. Why? Because it comes with a ready-made storyline. A giant asteroid from space slams into Earth, kills the dinosaurs, and clears the way for mammals to rise. It's got all the elements of a Hollywood movie: dinosaurs, explosions, and a clear villain from outer space. In contrast, the end Permian extinction doesn't have any celebrity species. There were no T-Rexes or velociraptors to spark our imagination, just strange fish, spiny invertebrates, and mammal-like reptiles most people have never heard of. So naturally, it's harder to turn that into a thrilling headline or a kid's cartoon. Next, there's the issue of fossil record bias. The creatures of the Permian, especially those on land, didn't leave behind a neat and plentiful fossil trail. Marine fossils are far more common than terrestrial ones, which means scientists know more about what happened in the oceans than on land. That skews our understanding and makes it harder to visualize the full scope of the extinction. Insects, for example, suffered a major blow during the end Permian event, but because they fossilized poorly, we have limited evidence. The gaps in the record make the story feel fuzzy, more like a half-remembered nightmare than a clear-cut event. Then there's the story itself, messy and hard to summarize. The KPG extinction, one big rock. Boom, global disaster, and easy to follow. The end Permian extinction, it wasn't a single moment, but a drawn-out series of environmental catastrophes stretching over tens of thousands of years. You had volcanic eruptions, greenhouse gas buildup, global warming, acid rain, methane release, and ocean anoxia. It's like a slow-motion apocalypse. This makes it hard to package for general audiences. There's no single dramatic image to point to, just a slow, suffocating decline. And let's be honest, that kind of complexity doesn't always grab attention in a world built on bite-sized content. On top of all that, the science is fairly new and still evolving. For most of the 20th century, the end Permian extinction didn't get much attention. It wasn't until the 1980s that scientists like David Raup and Jack Sepkoski began analyzing extinction patterns and noticed something massive had occurred at the end of the Permian period. Even now, researchers are still debating the exact causes and sequence of events. Some argue that methane was the key driver. Others focus on volcanic gases, while a few even explore asteroid theories. The ongoing debate keeps the story from feeling settled, which makes it harder for educators and the media to present it confidently to the public. And yet, the Great Dying deserves more than a footnote in history. It was the ultimate ecological reset, ripping the biosphere apart and forcing evolution to rebuild from scratch. Understanding it isn't just about honoring the past, it's about preparing for the future. Because of the same forces that once turned Earth into a toxic wasteland, they're knocking on our door again, in the form of climate change, ocean acidification, and carbon spikes. That's the real kicker. The more we learn about the Great Dying, the more it starts to sound familiar. The end Permian extinction wasn't just an ending, it was a reset. In the void left by the collapse of nearly all life, evolution took an unexpected turn. New creatures emerged, ecosystems reassembled, and the blueprint of life was rewritten. Without that moment of destruction, there would be no dinosaurs, no mammals, and no humans to ask what came before. It's strange to think, but our very existence traces back to a planet on the brink of lifelessness, where survival was a fluke and recovery was anything but guaranteed. Now we face echoes of that ancient crisis. Rising CO2, dying oceans, vanishing species. It all sounds familiar. But unlike the past, this story hasn't been written yet. We stand at the tipping point with knowledge the Permian world never had. So the question isn't just what happened back then, it's what will we do now? The Great Dying was a warning carved in stone and fossils. Whether we heed it or become the next layer in Earth's long memory is still up to us. If you found this fascinating, hit that like button, share it with someone who needs to hear it, and drop a comment. What surprised you the most about the Great Dying? Let's keep the conversation going.